precious metals, like gold and silver, are born from colliding dead stars. When neutron stars, the dense remnants of exploded stars, collide, they unleash an immense amount of energy, even greater than a supernova. These violent cosmic events forge and scatter vast quantities of precious metals, along with other heavy elements. In fact, some of the heaviest naturally occurring elements, including uranium, owe their existence almost entirely to these collisions. Both supernovae and neutron star mergers create heavy elements through a process called R-process nucleosynthesis. Under extreme temperatures and pressures, atomic nuclei rapidly absorb neutrons, increasing their atomic number. This is how elements like silver 47, platinum 78, gold 79, and palladium 92 are formed. So if you ever invest in gold or silver, consider their origins. These rare and valuable metals were forged in the heart of some of the universe's most powerful explosions. Only a small fraction of stars are truly white. To the human eye, many stars appear white, though some are notably yellow, orange, or blue. However, these colors are often subtle and can go unnoticed by casual observers. In contrast, photographs of the night sky reveal that most stars exhibit prominent colors, with only a small fraction truly appearing white. This is because stars behave like theoretical objects known as black bodies, which absorb all incoming radiation. As a black body is heated, it radiates energy, and its color depends on its effective temperature. The same principle applies to stars. Each star has an effective temperature that determines its peak color, which is why stars come in a range of hues based on their individual temperatures. Saturn's rings are amazingly thin. Saturn, the sixth planet from the Sun, is famous for its stunning ring system. Though they may appear solid from a distance, these rings are actually made up of trillions of ice fragments mixed with small amounts of rock. The particles range in size from tiny dust grains to massive boulders. One of the most astonishing features of Saturn's rings is how incredibly thin they are. Despite spanning nearly 140,000 kilometers from the planet's equator, their thickness reaches only a few hundred meters at most. In other words, the rings are hundreds of thousands of times wider than they are tall. To put this into perspective, a standard Blu-ray disc is 120 millimeters across and 1.2 millimeters thick. If Saturn's rings were scaled down to this thickness, the disc would need to be about 1 kilometer wide. Saturn's legendary rings might not be around forever. In fact, they're vanishing right now. Want to know why? Stay tuned for an upcoming episode all about Saturn. Thanks for watching. Before you go, please support the channel with a like, subscribe, and don't forget to turn your notifications on so that you don't miss anything from Absolutely Fact.